Alright class, so let's continue with this example C2H2 in describing the hybridization of carbon atoms which involve multiple bond. Alright, so this is the Lewis structure of C2H2, and next we have to determine the number of electron group around both carbon atoms in order to determine the type of hybridization. Okay, so basically you can see around this carbon atom we have 1 and 2 electron groups. So this carbon atom undergoes sp hybridization, and for the neighboring carbon you can see it also has a 1 and 2 electron group. So both carbon atom undergoes sp hybridization. Alright, okay, and in this molecule supposedly you can see around this carbon atom, the first carbon, it has 1 and 2 sigma bonds, and in one triple bond it contains 1 sigma bond and 2 pi bonds. And so same goes to the neighboring carbon. This is 1 sigma bond and it has in this triple bond it has 1 sigma bond and 2 pi bonds. Alright, and now we are going to describe the formation of sigma bond first. Okay, let's continue. Alright, so this is we are going to describe the process of hybridization undergo by both carbon atoms, but since they are identical, they are same, so I will explain once for the hybridization of carbon atoms in this molecule. Alright, so this is the electronic configuration of carbon, 1s2, 2s2, 2p2, and this is the electronic configuration of hydrogen atom. Alright, okay, so now let's start describing the formation of sigma bond, the hybridization process undergo by both carbon atoms. Okay, so in the ground state, in 2s orbital of carbon, it contains 2 electrons, and in 2p orbitals it contains 2 electrons. And from the Lewis structure, let's say I refer to this carbon atom, so we have 1 and 2 sigma bonds. So in order to form 2 sigma bonds, this carbon atom needs 2 unpaired electrons. So from the valence electron orbital diagram, you can see 2 unpaired electron is there. Okay, sudah ada kat sini, already there. But if you do not promote 1 electron from 2s, it shows that carbon atom has lone pair, so it is totally wrong. So you have to promote 1 electron from 2s orbital to 2p orbitals. So now we have 2s, 1 electron left, and in 2p orbital of carbon, right, there are 3 electrons, and total now we have 4 unpaired electrons. And previously, earlier before, we have already determined the type of hybridization for both carbon atoms. Both undergoes sp hybridization. So each carbon undergo sp hybridization. So the carbon atom will mix its 2s orbital and one of its 2p orbitals to form a new set of hybrid orbitals, which is called sp hybrid orbitals. So now in each sp hybrid orbitals it contains 1 unpaired electrons, and now we have at the right side 2 2p orbitals which are unhybridized. Okay, so let's say 2p orbitals which undergoes hybridization is 2px. So 2py and 2pz orbitals does not undergoes hybridization. So here there are 2 electrons occupied 2p unhybridized orbitals. Alright, so from the sp hybridization or from the sp hybrid orbitals, you can see these electron will be used to form 2 sigma bonds for each carbon atom, and these 2 unpaired electrons occupied 2p unhybridized orbitals will be used to form 2 pi bonds. Okay, alright, so now let's continue with drawing the orbital overlapping. Alright, okay. Okay, so in sp hybrid orbitals of each carbon atom, it contains 2 unpaired electrons, and there are 2 2p unhybridized orbital which contain 2 unpaired electrons. Okay, and this is the Lewis structure just now. Okay, and I'm going to show the orbital overlapping which form the sigma bond between carbon atoms. Alright, okay, so both carbon atom undergo sp hybridization. So the electron group arrangement for sp hybrid orbitals is linear. Okay, so this sp orbital has linear arrangement. Alright, sp hybrid orbitals, there are 2 loops, 1 and 2. So let's say this is for carbon atom. Okay, so I label it here. Okay, sp. Okay, and it contains 1 unpaired electron, 1 unpaired electron here. Okay, so the sigma bond between carbon atoms is formed when sp hybrid orbitals of the first carbon overlap with sp hybrid orbital of the neighboring carbon, and the overlapping is end-to-end overlap. Okay, so sp. Alright, shared electron, and now this is the sigma bond form. So another one hybrid orbitals of the second carbon also contains 1 unpaired electron which will be used to form the sigma bond later on. Okay, so settle with the sigma bond between carbon atoms. Okay, so now I'm going to show you the formation of sigma bond between carbon and hydrogen. Alright, so the valence electron of hydrogen occupied 1s orbital. So the sigma bond is formed when sp hybrid orbital of carbon overlap with 1s orbital of hydrogen. Okay, so let's say this is 1s of hydrogen. So here is the shared electron. Okay, shared electron with opposite spin. Alright, okay, and now the second sigma bond is formed for the first carbon. So continue with the second carbon atom. So sp hybrid orbital of carbon, right, overlap with 1s orbital of hydrogen. So in the overlap region, it contains shared electron with opposite spin. So now the sigma bond is formed. Okay, so settle. Okay, so the pi bonds, there are two pi bonds in the between carbon atoms. There are two pi bonds between carbon atoms. So the pi bond is formed when unhybridized 2p orbitals of each carbon atom overlap, undergo side to side overlapping. Okay, so let's say 2px from carbon atom undergo the hybridization, so it form sp orbitals. So 2py and 2pz from the carbon atom does not undergo hybridization. So let's say this is 2py, 2pz. Okay, so I want to show the first pi bond, the formation of the first pi bond. Let's say the 2py from the first carbon overlap with the 2py from the second carbon atom. So let's say this is 2py. Okay, let's say I label here 2py. It contains one unpaired electron here. Okay, one unpaired electron. So the second carbon also has 2py unhybridized orbital. So label it as 2py. It contains one unpaired electron. But to form the sigma bond, both 2py unhybridized orbitals undergo side to side overlapping. So in the overlap region, there is shared electrons. So here you have to draw electron with opposite spin. So overlapping from both 2py unhybridized orbital, side to side overlapping will form one pi bond. Okay, settle with the first pi bond. Okay, now continue with the second pi bond, same like the first pi bond. Okay, so let's say now 2pz undergo overlapping with another 2pz from the neighboring carbon. Okay, so alright. Okay, so now let's say I use brown color for 2pz. Okay, so let's say label it as 2pz. It contains one unpaired electron. Okay, and same goes to the another carbon. So this is 2pz unhybridized. It contains one unpaired electron. But when overlapping, the both orbitals undergoes overlapping. In the overlap region contains two shared electron, the shared electron with opposite spin. So now this is the way how to show the overlapping, side to side overlap. It will form the second pi bond. Okay, so it align with the Lewis structure of C2H2 molecules. Okay class, so I hope this video really helped you. Okay, thank you.